Hi guys, in this video we're going to be interviewing a real-life geologist, Gordon Barnes, who works here in Orange. Hi Gordon, how you going?
Good, John. Hi, everyone.
So firstly, you're a geologist. What does that mean you do? What do you do as a geologist?
Well, my job's pretty varied, but basically to be a geologist you try and understand, the history of the Earth and all of the processes that go on to form the land surface that we currently work on and what's gone on previously, and trying to understand all of those processes depending on your area of expertise, to figure out which sorts of things are significant and where you should be looking for certain things.
Okay, no worries. So what does your day look like when you get to work?
My day right now is pretty boring. I sit behind that desk over there most of the day looking at a computer and looking grumpy. So I won't tell you about that, but
Yep.
I'll tell you about my early days as a geologist, which was a lot more exciting because mostly I was in the field, and you get to work in a whole variety of places, but typically you'd be on a project somewhere. I'm a mineral exploration geologist, so we're looking for minerals. I've worked in most states and territories of Australia and numerous countries overseas, and you're basically out and about, out in the field, picking up rocks, trying to figure out what the hell's going on and where to look next. And you're working with various other people from other companies, drilling companies and geophysical survey companies and the like. And you get to work in lots of interesting places and meet lots of interesting people, and generally have lots of fun. It's hard work, but it's good fun and rewarding.
Okay, so you talked about a few of the different people that you're working with there, and my understanding is that they're also geologists. So what different fields are there in geology that you could get into?
Well, collectively, you can refer to it as geoscientists. So there's geologists who are interested primarily in the rocks. There's geophysicists, which look at the physical properties of the rock and then try and use remote detection systems to help you understand the underlying bedrock, because particularly in Australia, the bedrock is not exposed. It's all soil or sand cover, and you can't actually see any of the rocks. So you have to use geophysics to try and figure out what the basement is. Then you have geochemists who study the chemical properties of rocks. They're the main ones, and there's a whole series of other specialists as well, like paleontology and so on. So there's a diverse amount of careers. So generally, collectively, we just refer to ourselves as geoscientists.
Okay, so no worries. So what type of education would you need to be a geoscientist? Would you go to uni, or
Yep.
what would you study?
Yeah, you need a base degree, which would be generally a 3-year degree, quite often a 4-year degree with honours. So to be in one of the physical sciences, I actually did my undergraduate course was called Applied Geology. But you can also study geophysics as well, and various sub-disciplines of geology and geophysics. So basically a minimum 3-year bachelor degree. Quite often you might do an extra year for an honours project. And then quite a lot of people will then go on and do higher degrees, either master's degrees or PhDs. I did a master's a few years after graduating and found that very beneficial and useful in my career.
Okay, so there's a fair bit of education you need to sort of get forward in the field.
Yep.
Going back a little bit, what type of things at the school level do you still use on a daily basis? So what type of skills and things that you learn at school are you still using?
If you're going to pursue geology or in fact any of the sciences at degree level at university, you really need to have a good background, a good understanding. In particular, chemistry is probably the most important one, and fortunately I quite enjoyed chemistry at school. I'm not sure if the year 8s are doing chemistry yet.
They do a bit of chemistry,
right?
Yeah.
So yeah, chemistry, you'll need to have that at what used to be called HSC. I'm not sure what it's called these days, but
yep, still HSC.
Oh, is it? Okay. Yeah, that was in Victoria. I went to school in Victoria.
PCE,
yeah, they call it something different. So yeah, chemistry, physics is actually quite a useful thing as well, although at the time I didn't realise it, and a lot of it went over my head. Um, Mathematics is actually quite important, in particular statistics, because in my area of speciality, where we are looking for anomalous populations or anomalies, and you've got to define those using statistics, so statistics is very important. And then finally, a lot of what I do is about communication. So I have to write a lot of reports to various stakeholders. So yeah, it's quite useful if you can know how to write a report and you're good at English.
Yeah. And then that's where the business side comes into it.
That's where the business side comes into it. But also, if you go into other, academia or whatever, you still need to be able to communicate properly, and that requires, good report writing skills.
So that's all great, Gordon. Is there anything else that you want to add for the guys? Something that might be interesting for them to know?
Yeah, it's worthwhile remembering that when we walk past certain things. Everyone lives in Orange knows that there's a big mountain just out here called Mount Canobolas, and it's static and it looks like it hasn't moved and all that sort of thing. But I think it's really important to understand scale, particularly in the geosciences. So we tend to measure our passage of time in days and weeks and years and so on. But it's important to remember that the Earth's incredibly old and it's incredibly dynamic. So even though in a lifetime Mount Canobolas hasn't moved or it doesn't look like it's doing anything, there's a hell of a lot of geological processes going on, and the Earth is an incredibly dynamic planet. But you need a good perspective on scale to understand that. And we tend to spend a lot of time looking at maps. I love maps, and I like looking at maps when I was a kid and used to draw them. And my office is surrounded by maps, and we use maps every day. When you look at these maps, you get to understand the really dynamic processes that went on to generate where we are now. So, in the case of Mount Canobolas, it erupted about 13 million years ago, but it's a hotspot volcano, so it's extinct. It's not going to erupt anymore. And because of Mount Canobolas and previous geological processes, the whole area of Orange was uplifted, and we're about anywhere between 850 and 1,000 metres, and that's critically important for the microclimate that we have here now. So while it's 40 degrees in Dubbo, it'll be 30 degrees here, and that's because of our elevation. It's generally greener. It's more favourable for things like wine growing.
And that's all caused by that volcano that happened 13 million years ago.
And plus a lot of sexy stuff that was going on about 450 million years ago, which set the foundations in place. So basically, how we interact and what we do in day-to-day life in Orange and anywhere for that matter is really governed by the geological processes that went before us. So, and I think it's useful to keep that in perspective when you're thinking about these things.
Excellent. Well, thanks very much for joining us today, Gordon.
No worries.
This has been an interview with a real-life geologist.
See you
Peace out, guys.